So this is CPM Precalculus, Chapter 1, number 40. So in this problem, we're given two graphs, A and B, and we're asked to find a reasonable equation for each one. Okay, so for this one, we have to think back of parent graphs. Parent graphs. And we kind of talked about, like, we all have parents, and parents give birth to children. Well, parent graphs go through transformations, and new graphs are created. Okay, there are, I believe, there are 6 parent graphs in general, or 6 main ones, but we so far have looked at 6 of them. Out of the 12, we've done half. So we have y is equal to x squared, y is equal to 1 over x, y is equal to absolute value of x. I'm sorry, there are more than 12 parent graphs, but we looked at 6, and we will be looking at least 12. Y is equal to x cubed, y is equal to 2 to the x, y is equal to square root of x. And we even know the sketches for these. The rough sketches, we know this one, it goes like this. It's a parabola, we know it. This one, it's like this, right? Check your notebooks. Absolute value, we know it's like a v. X cubed, we know it goes up here, plus 9 goes down. 2 to the x, we know it goes like this. Plus that 1, 0, comma 1. Square root of x, we know it starts here and goes to the right. Okay, so these are our 6 parent graphs that we know of right now. So we also looked at, in the last few homework sets, we looked at transformations, or what doing something small to a graph can like make it go wider, can go narrower, can shift it, and things like that. So looking at part A, okay, A, we have this as our new function, or our baby graph, right? So which parent does it look like it came from? I'm looking at y equals x cubed, right? And then I see that this is similar to y equals to x cubed, but instead of being at the origin, it starts over here at 2, so 1, 2 to the right, 1, 2, 3 down. So this point is 2, comma, negative 3. So it doesn't start at the origin, which is right here. It starts over here. Okay, and also it doesn't go from the right to the middle to the down like our sketch does. It goes from the left in quadrant 1 up here to the middle, and then goes down to the right. Okay, so kind of, we could see that as if there was some type of flipping going on. Okay, so flipping, we call reflecting across the axis. So there was a flip across the axis here. It could have flipped across the x-axis or the y-axis, either one, but we know it flipped across the axis. So if we start with y equals to x cubed, and we want to flip it across the x-axis or the y one, we basically make it negative x cubed. Negative x cubed is going to basically flip it across the x-axis. Okay, so reflect, I'm going to move down across x-axis. So what that's going to do to our, from our parent graph to our new one, it's going to reflect it. So instead of starting down there, it's going to be going down that way and like that. So it kind of flips it as if there was a mirror right here in the middle on the x-axis. It flips it. We could have put this in quotes, and then it would have, not quotes, in parentheses, and then it would have flipped across the y-axis. But either one will be okay. I'm going to leave it like this because I wrote it reflects across the x-axis. Then we notice that it doesn't start at 0, 0. So this is done in 2 steps. One is it moves to the right by 2 units, right? It moves to the right over here by 2 units. and then it moves down by 3 units. So it moves down by 3 units to get our final graph, right? Something like that. So how do we get this? So we have to remember that in previous problems we looked at, for example, let's see. We looked at number 15. Okay. In previous problems, like in 1:15, we looked at y equals absolute value of x plus 5. And we noticed that this plus 5 makes the parent graph, y is the absolute value of x, move up by 5 units. And then later on, we looked at the graph in number 17, x plus 2 cubed, compared to the original graph, y equals x cubed. This right here moved the graph to the left by 2 units. So if we're trying to move this, right, we want to move this to the right 2 units and down 3 units. So first, to move it to the right 2 units, we don't want to move it to the left, we want to move it to the right. So we're going to take x minus 2. That's going to move it to the right 3 units. Right, shift, right 2 units. And then y equals to negative x minus 2 cubed. We want to shift it down 3 units. Minus 3 is going to shift it down 3 units. So we can get this as our answer to part A. Now, really think about how we got this. We did it in a few different steps. We reflected our cubic function, x cubed, across the x-axis. Then we shifted it to the right by 2, and then shifted it down by 3. So it's important that you are able to see this as like the cubic function with some transformations. Okay, so now let's look at part B. So let's look at the graph of B, and I'm going to take off all that other stuff. So this one now, which parent function does it look like? Before I take that off, let me put it back and look at all these. So it's not x squared, it's not 1 over x, it's not the absolute value of x, it's not x cubed. This one kind of looks like 2 to the x. Okay, so keep that in mind as our parent function. So this one, like I just said, the parent function, the parent appears to be y equals 2 to the x, right? That function has the property at x is 0, hits 1, it never gets negative and goes like this, right? So this is y equals 2 to the x. And this one, we know, what do you think happens? I mean, realistically, just a good approximation would be, we want to shift this to the right and down, right? If this is our original function up here, we want to shift this point, maybe we want to shift this point to right here, for example. So that would mean we want to shift it to the right by 2 and down by 3. Well, very similar to part A. Okay, so to shift it, but we're not reflecting it across any axis. So to shift it to the right, so shift right by 2 units. Okay, to shift it right by 2 units, wherever x is, we subtract 2. Okay, so to move it to the left, we add 2. To move to the right, we subtract 2. Okay, and then shift it down by 3 units. Shift down by 3 units. We have y equals 2 to the x minus 2. From that, we subtract 3. So if we put the subtract 3 on the outside, that's going to go up and down. If we add or subtract to our x on just where x is, it's going to shift it to the left and right. So this is the answer for part B, and that will conclude Precalculus chapter 1, number 40. Okay, those are the reasonable equations for each of the graphs here. B is going to be y equals 2 to the x minus 2 minus 3. So think about these, and so I'm just kind of going over them for you so you can kind of see them, but really think about what I'm doing when I'm shifting by 2 units right and left. So here right, subtract 2, down, subtract 3. If we wanted to go up, it would be plus 3. So just think about this as we move forward. Okay, so that ends number 40.